Hello and welcome to all students. In this lecture, we try to solve some examples on subspaces. Let us consider first example. Prove that the set of all bounded sequences on R is a subspace of a vector space of all real sequences over R under the usual operations of addition and scalar multiplication. So in this example, we have given the vector space is given here. It is a set of all real sequences, and the subset is given here is the set of all bounded real sequences. Okay, and we have to show that this subset is a vector space of the set of all real sequences. Okay, so that is very simple. Let us write here, let V is a set of all real sequences and W is the set of only bounded real sequences. We know that V under the usual addition and scalar multiplication is a vector space over R. We want to prove that W is a subspace of V. Now we show that W is a subspace of V. First of all, we show that W is a non-empty subset of V. So consider the 0 sequence 0, 0, 0, 0, dot in V. And this sequence is a bounded real sequence. Therefore, it is belongs to W. The sequence is bounded sequence of real numbers and hence it belongs to W. Therefore, W is non-empty subset of V. Now we show that for all An and Bn belongs to W, any two sequences A and Bn belongs to W, and any two scalar PQ belongs to R, we try to verify this property PQ, P into An plus Q into Bn is also belongs to R. So recall that sequence An and sequence Bn are bounded sequences, then sequence An plus Bn is also bounded sequence, and also sequence P into An and sequence Q into Bn are also bounded sequences for PQ belongs to R, since sequence An and sequence Bn belongs to W and W is a set of bounded sequences. Therefore, sequence An and Bn are bounded. Therefore, using second, for PQ belongs to R, PAN and QBN are also bounded. And now applying 1 to PAN and QBN means their addition of bounded sequences is also bounded sequence. Therefore, this sequence belongs to W. PAN plus QBN is a member of W because it is a bounded sequence of real numbers. Okay, therefore by the theorem on subspaces, W is a subspace of V and it is as required. Okay, now let us write some examples for practice. Solve the following examples on subspaces. First example is, show that the set of all differentiable functions from set of real numbers to the real numbers is a vector space over R under the usual operation of addition and scalar multiplication. This is first example for practice. Try to solve at your own. And second example is, in the set S equal to ordered triple, set of all ordered triples x, 1, z such that xz belongs to R is a subspace of a vector space R3 over R. Third example, check whether the set S equal to ordered triplet, it is the set of all ordered triplets like this. First component is x, second component is y, and third component is xy, so that xy is they are real numbers is a subspace of the vector space R3 over R. And fourth example is show that S equal to set of ordered triplets x comma y comma 3x minus 2y such that xy they are real numbers is a subspace of the vector space R3 over R. So these are the examples, and try to solve these examples at your own. And we stop here. Thank you for listening this lecture.